अरे हमको सब सुनाई दे रहा है।
Okay.
चलो।
Okay, fine. Okay, my screen should be visible to you. Okay, I hope so. Okay, today, next week, possibly also next to next week, we will study about shell programming. This is yet another kind of programming, and we will concentrate on this shell, BASH, which is an abbreviation of born again shell. Okay. Today I will not.
Sir, born what?
Again.
Okay.
I will come to that. I will come to that. I'll make a listing of all these common shells. Whatever. Yeah. So today I will not talk much about programming the shell, but just about how variables, arrays, associative arrays, and similar things can be written in this bash shell. This kind of thing. And other constructs like return from functions and let's say things like looping, condition checking, and all that stuff. These things we will see in the next or two next classes. Okay, so let me switch to the presentation mode. Okay. So first of all, the question is, what is a shell? It is nothing but a command interpreter. Okay. And whenever you open a terminal, a shell is usually opened depending upon what kind of default shell you have. And you can run this shell interactively when you open a terminal. And from a terminal or somewhere else, you can also call this shell non-interactively. So then an interesting thing is that a shell can be programmed like a high-level programming language. So still, why should we use shells? Maybe in the next slide I will give you some justification. And here are some common Unix shells. This is perhaps the first shell, SH. This is the Bourne shell, but written only as SH because it's named after Steve Bourne of AT&T Bell Labs, where this Unix and C were developed in early 1970s. And this is basically, bash is basically a modern version of this original Bourne shell. It has some extra features, otherwise it should be fully compatible with SH thing. Okay. But anyway, so there are several new features. So bash is perhaps the currently most used Unix or Linux shell. So we will study this bash. And there are other shells like TCSH, KSH, CSH. Okay. Restricted shells like restricted bash, restricted K shell, and all that stuff. Anyway, so different shells have slightly different syntaxes, and in some cases these syntaxes are widely different. So we will stick to some shell, and let us say this is bash. And once you know what a bash shell does, how we program it, you can learn the syntax of any other shell like CSH or TCSH, and you can port your programs to these other shells in a similar manner. It doesn't create much difficulty. Only thing, some syntaxes you should be careful about. Okay, so here are some initial things. So whenever you log in, some file called etc/password is read about some information about your login and default directory, home directory, and also some your default shell. And in current days, most Linux versions supply bash as the login shell by default. Okay. But in any case, there is some command called chsh. So this is change shell. Using this, you may change your login shell like this. Okay. For that, you need to enter your password. Okay. So there are some utilities that may be handy to you. So now let us see. If I assume that you have all these shells listed, bash is your default shell. So whenever you open a terminal and echo something called sh means shell, lvl means level. Shell level, it is 1. It is the outermost shell that is running. Okay. So we'll soon see what echo does and what this so-called environment variable does. It stores the level of the shell. Okay. And this is open in the interactive mode, so you can keep on typing commands and get appropriate actions against those commands. In particular, you can run another shell here. Like if I run this TC shell, then it gives some slightly different prompt. Let us call it %. Okay. And here, if you echo the same environment variable, you will see 2 because this is the second level of shell. From here, you may run another shell like this K shell. And once again, if you echo this, you will get 3. And from here, you may run bash. And now you echo it, it will be 4. And exit is a way by which you can exit from a shell. So whenever you say exit, this bash comes out and you come back to this K shell. Again, exit. You come back to this TC shell. Once again, say exit. You come back to the original level 1 shell, which is your bash maybe by default. And here, if you say exit, basically your terminal will close. Okay. Okay. Just before trying to use this, I would say, shell as a programming tool, let us see that you can also run a shell in the so-called non-interactive mode. So run this shell with the command -c, and then whatever commands you want to specify, you want to run, specify one after another, separated by semicolons. Semicolon is a separator, not a terminator. It's not like C. So suppose I want to see the calendar of March to 2022, and then write a small message called fortune. Okay, so you can install these things, fortune, in your Linux box and see what it does. It actually gets some kind of often funny quotes like this. Okay, and this is non-interactive, so this shell executes only these commands and then terminates, and therefore if you echo this shell level, it is once again back to 1. Okay, if you echoed it here, you have seen 2. Okay, anyway, so for the rest of these slides, we will typically not use this non-interactive mode, but you note that whenever you write make file, then each line is executed by a shell, whatever you supply here, sh equal to whatever or colon equal to whatever. So it opens a shell, runs those commands in the non-interactive mode, and returns back to the next line. Okay, so you know this thing, right? In a makefile. So for every line, a new shell is opened. In the non-interactive mode, whatever you asked to do there, it does, and then comes back. Okay. Anyway, so for the rest of this course, I would say we will not much worried about this non-interactive mode of running it. And here is yet another thing. So there are certain files where some startup instructions are given, like initializing your default shell variables, environment variables, setting up some kind of aliases and so on. So this is the system level startup function, and inside your directory, home directory, tilde is your home directory. Your files are searched in this order: bash underscore profile, bash underscore login dot profile, and all that stuff. And you can initialize many things there. Okay. And for interactive non-login shells, you can use this bash rc. They can be the same file actually. Anyway, it doesn't matter. And you can also write something like a bash logout file, the last thing you want to do before logout. And yeah, so these are not very important. You just go through this. Okay, so from here onward, exact, I would say, coverage of this material starts. So what is an environment variable? Okay, so the shell starts with a set of default variables called the environment variables. Okay, so what are these variables? Okay. So in a non-interactive shell, these variables are stored in an associative array called bash underscore env. And if you are in an interactive shell, you can simply type set return. Okay, you will see a lot of lines giving you the values of the environment variable. For example, bash is this, number of columns in your terminal is 100, your group, your home, your host name, language encoding, number of lines in the terminal, your log name, OS type, path, blah, 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 lots of things, including SHLVL. And of course, there are some 100 lines you will see, and I am showing you just some 10, 15 of them. Okay. So this environment variable stores some default things. This path is an important thing. Whenever you say some command, where will it search? Okay. So this path variable essentially is a colon separated list of default directories where the command is searched for. Okay. In the sequence from beginning to end. For example, if you write something like Firefox, it is not necessarily stored in your current directory, and even if it is so, this dot should be explicitly in your path. Otherwise, the shell does not search for whatever command you say in this dot. Okay, so Firefox, you say, you first search in this directory, not successful. Maybe you search for this directory, not successful, not successful. Maybe it is there in user bin. Then it finds Firefox in an OpenShift. Okay, and if there are multiple files of the same name residing in the same different directories, then of course the first one found will be executed. Okay, I will let us see. I can augment path by my own directories. Okay, we will see. So PS1 is basically the prompt. This is the primary prompt. This is the secondary prompt, and there are PS3, PS4. These all have some meanings. Anyway, so there are many such environment variables, and you can read them, take certain actions based upon them. And unless an environment variable is unless it is read-only, you can also change them to suit your needs. For example, you can set your prompt, okay, by changing this variable. Okay, this is not a read-only variable. Path you can change. You can add certain other directories to this from where it will search for executable files. So you can change paths. Okay. So unless it's a read-only variable, you can change it. And if it is a read-only variable, then of course you can only read it. Okay. Now, in addition to these default variables, you can have your own variables. So these are called user-defined variables. So this is what I start. Sir? This is yeah, tell.
Sir, what is that bash env?
Okay, here if you are in the interactive mode, then you can say set, or you can say some variable name, set variable name, then it will tell you to what value it is set, or all the variables are set. Okay, like this. But in a non-interactive cell, you cannot do it non-interactively, right? You cannot do it interactively. Okay. But still, these, I would say, definitions of default variables are available. Okay, so you can use them. Okay, and they are stored in something called this associative array. You know associative array by this time, right?
Yes, sir. Yes, sir.
Because we have seen this in connection with awk. Okay, so this is an associative array. This bash maps to this, columns map to 100, hostname maps to FB server, path maps to this string, and so on. Okay, so you can get individual things from this associative array. So it's basically that thing, nothing more serious than that. Okay, so now
Sir, do environment variables exist in all operating systems?
in Unix systems, you always have these things.
Sir, we have this thing, right, in Windows, set environment variables.
Windows
After
what will happen, I do not know. Or if you go to some other thing, Mac, what will happen, I don't know. Well, anyway, Mac is based upon Unix, BSD Linux basically, BSD Unix. But we will mostly concentrate on Linux type of machines. Of course, there is no system which is fully Linux, fully Unix compliant. So we choose Linux because that is apparently the second most popular, I would say, operating system after Windows. Okay. Mac is another interesting thing. It should support similar things. Okay, but its commands, syntaxes, all these things are slightly different. And in India, I believe Linux is more popular than Mac machines. So let us stick to this version of Unix, Linux. Okay. And we will typically use this bash, which is by default the login shell of every person. Okay, you may change it to some other thing using CSH. For example, I am personally very much hooked to the C shell. So for me, the default shell is not bash, it is TCSH. But anyway, that's my personal choice. Bash is the most widely used shell in the Linux kind of environments. Okay. So what other operating systems do, that is not exactly, I would say, determined for the moment. If it is a Linux-like system or a Unix-like system, it should do something like this. And it may not have this bash, but it will definitely have SH, the original bourne shell. Okay. And many of the syntaxes that we study in connection with bash, we will also apply on this original SH. Okay. Okay, any other questions? Okay, perhaps no. Okay, so now let us go to the programming part. Okay, although I do not say shell programming for the moment, but anyway, if you want to write any program, you should have your own variables. In addition to whatever default is provided to you by the system, you should have your own variables. Okay, so these are called user-defined variables, and they can be defined by the user, new variables, and you can use any name that you can use in C. Okay, so the naming conventions are very similar to as followed in C. First one should be underscore or any alphabetic letter, uppercase or lowercase. This will followed by any sequence of uppercase and lowercase letters, numeric digits, digits, and underscore. Okay, same naming conventions apply to shell variables. Okay, and you can define a new variable as this. In the dollar prompt, you simply name the variable, then equal to, then the value. Note that in C or awk, spaces between these and equal to and equal to and this value are permitted. Okay. But if you do bash programming, or if you are in the bash shell in the interactive mode, or even in the non-interactive mode, perhaps, then there should not be any space between this and this. Okay, I think this is the next thing. Spaces are not allowed immediately before or immediately after this equality sign. So this is a peculiarity of this shell, because if you separate this by a space, then basically what the shell will try to do, whatever you supply as this variable name, it will try to find a command of that name. Okay, so do not do this. Do not separate this variable and the value by, any spaces before or after this equality sign. Okay. And how do you access this variable? It is no longer by simply telling var, but you have to tell access the value of var as $var, or you can enclose this name by a pair of curly brackets, braces. Later we will see sometimes giving these curly brackets is mandatory. Okay, we will see. Okay, when you study associative arrays or simply arrays, you have to use something like this. Otherwise, the shell cannot parse it. But if it's a simple variable, then you can simply call it $var. Okay.
Sir?
Yeah.
Sir, when I'm printing the value of the variable, so it does print it, but after that, it immediately prints command not found.
What is not found?
Command.
I don't know what you are doing.
So I think he has to use echo before the variable.
Yeah, echo you have to do. I will show you. I will show you. Please wait. Okay. And a variable can be undefined. You are using this unset variable name. So let us do this thing. Let us look at this example. So let's say I define a variable my underscore name and assign it the value this. Okay. Then what I want to do is something like this. My underscore full underscore name equal to this, followed by a space, followed by another thing. Okay. Now, just because I didn't quote this thing, the shell assumes that this value will initialize this new variable or set this variable. And this is something like a comment. Okay. And it will say this is command not found because it is considered after this assignment, after this setting of this new user defined variable. So spaces have a role to play when you talk about shell programming. So you should understand these things clearly. So command not found. However, if I quote it, okay, then there is no problem. Okay, it simply assigns. Now this space is actually part of this string, and therefore this entire string will populate or initialize this variable like this. And you can print this thing using the echo command. Okay, so echo is kind of print in a single line. Okay, echo this. Of course, there is echo minus n. I will come to that later anyway. So you should not print simply my name here. Okay. And if you say echo my underscore name, it will echo just my underscore name. Okay. So you have to use this $sign in order that the shell understand that you are talking about the value of a shell variable. Okay. So this is the first time you are seeing that a variable which is my underscore name and its value which is $my underscore name, these are treated differently. Okay, in C you can say I equal to 3 and you can simply print I. You do not need to print $I or something like that. But here you have to do it. Okay. And you see other examples, echo $my underscore name. You can also say multiple echo things, multiple variables echoing like this. Or you can run multiple echo commands by echo this, semicolon, echo this. Okay, and you will see things like this. And you can unset this variable by this name. And then if you try to echo it, it will give you an empty line, indicating that nothing is defined here. So an undefined thing automatically implies the empty string. Okay, so the empty string is printed, and after that, this new line. Okay, so this is how you can define simple user-defined variables or user variables. Some name followed by no space. Immediately after that, it should be an equal to, and then you supply a value. If needed, code that value. Agree?
Sir,
Yeah, tell.
sir, suppose in the line where you have echoed my name and my full name without a semicolon. Like suppose between the dollar my name, then we followed by 3 spaces, followed by dollar my full name. Like then will there be 3 spaces printed between the two strings or like?
Oh,
how?
3 spaces here, 3 spaces.
Yes.
No, only I think only 1 space will come. Now you try it out, but I believe because with the command interpreter, you try it out and see what happens. I think there will be only 1 space because multiple spaces are treated as 1, unless quoted. Of course, if you just quote this followed by 3 spaces, then this quote end, then 3 spaces will be printed.
Sir, please repeat the last part.
Okay, if you have 3 spaces, although I have not tested this, my idea
Yes,
is
sir, it shows 1 space only.
1 space only. But if you do this thing, 3 spaces, then this, but put everything in a quote like this, then 3 spaces will be printed.
Okay.
So I don't think the echo program actually receives the spaces, right? It's just receiving arguments through argc and
Yes, exactly. It is just saying arguments. But if you quote it, then it treats as a single argument and it will expand this variable here, 3 spaces, because that is quoted, and then this will be expanded. So quoting means this is just a single argument. Agree?
Yes, sir, works.
Yes. Okay. Good. Okay, so that's about it. Simple variables and their definitions. And note that even if this is a numeric string, okay, like you say age equal to something like 30. Okay, this 30 will go as a string, not as a numeric variable. If you want to do some kind of numeric operations like arithmetic operations, you need to do it with some special things, which will automatically convert numeric strings to numbers, corresponding numbers. Okay, these things you can do, but note that whatever values you supply, they will go for the moment as strings. Even if these are numeric strings, they are not immediately converted to the corresponding number. Okay, so be careful. Again like awk. So when there is an automatic conversion from strings to numbers and numbers to strings, this thing you have to worry about. Okay, by default these things are strings. Okay. Okay, good. Okay. Now maybe a little bit premature to talk about this. Here I have used a pair of double quotes, and if you look at your keyboard, there are 2 other types of quotes. One is the forward quote, okay, which is basically just sitting below this double quote, and the other one is called backward quote, and it is usually on the top left corner, near the top left corner of your keyboard. These three things have entirely different meanings in the context of a shell. Okay. Not, I would say, entirely different, but yeah, this backquote is actually entirely different. Forward quote, single forward quote, and single double forward quote, or double quote. Double, yeah, you do not have backward double quotes. Okay, so these things are sometimes similar, but there are some dissimilarities also. So let us look at this. Okay. So double quotes. So this is the difference between double quotes and single forward quotes. If you have things like dollar followed by a variable name, this will be expanded if it is within double quotes. Whereas if you have single, okay, so if you now want to print this dollar literally, just escape that using a backslash dollar. Okay, then the shell knows that you are implying a literal dollar and do not want to expand a variable after that. And if you quote your string using a single forward quotes, then this dollar is always taken literally and no variable expansion will happen. So that is the difference between double quote and single forward quotes. Understood?
Yes, sir.
Okay. And backward quotes is something rather confusing to you to start with, but we will later pretty often use these backward quotes. Okay. This essentially says whatever is written inside those pair of backward quotes, you execute this as a comment. Okay, so let us look at this example. So once again, you define like this. And if you say echo welcome my name without $sign, then this is definitely this. And since no variables are involved here, there is no distinction between a single quote and a double quote here for this. Because this is a literal string. And since dollar is not there, there is no, I would say, obligation on the part of the shell to know that this is a variable and I am looking for its value. So in order that I want to let the shell treat this as a variable and I'm interested in the value of that, so I have to say dollar. Okay. So then this is expanded and it's written like this. And if you want to code this, just say this, then this is no longer evaluated. This is no longer a variable name. It simply prints this. And if it is a single quote, then anyway, this dollar is never evaluated. So this is printed. And if you say this thing, this will also be printed. Okay. Now, if you do this backward quote, then what shell will do, it will try to execute this part as a comment. Of course, it will evaluate this my name and it will try to execute a comment called welcome. Then whatever is followed by this, colon space Barik, this will be there. And whatever that command is supposed to output, this will be echoed. But I believe in most of the machines, there is no default command called capital WELCOM, welcome. So the shell complains that this command is not found, and therefore nothing is echoed. Actually, this empty string is echoed followed by a new line.
So can you repeat how is the output coming?
So I think a good example of this is using PWD or LS inside backquotes and echoing that.
I will come to that. There are more examples in the next slide where actually we can use this backquote thing. In fact, we will use these backcodes quite extensively later. For the moment, it's just to give you an initial flavor of what backcode does. So note that this single backward codes execute the command after variable substitution, if any. Here there is a variable substitution. It will make this variable substitution. And whatever is appearing between this pair of backward codes, shell will try to execute that thing as a command. And whatever that command outputs, okay, to stdin, that will be used as the argument of echo. Okay, but since my system does not have a command called welcome, it simply says command not found, and therefore echo gets no argument. So it simply prints a blank line, comes back to this dollar. Understood now? Yes. Okay, let's look at more realistic examples where I can actually use this backward code thing. Okay. Okay. If you simply say ls /, you are essentially looking at the files sitting in the root directory. Okay, so you will get a listing like this. Okay, so this is what is printed to your std out. Now what I am doing is this thing, whatever this ls / returns, not returns, I would say prints, this I pass to echo. So echo will now echo it in its own way. Agree?
Sir, please repeat.
ls, if you just say ls /, okay, it will give a directory listing of the root directory. Yes or no?
Yes, sir.
Okay. Instead of doing that, immediately printing that value to your std out, what this will do, it will simply pass that whatever is printed to std out to echo as arguments. So echo will receive something like echo bin, boot, cd-rom, device, etc, home, blah, blah, blah. And it will print this thing in its own way.
Sir,
Yeah.
sir, without the echo, if we just write ls and /,
Yeah,
then also.
we will get a similar type of.
Yes,
similar,
sir.
Yes, yes. That's why it is confusing to you why I am doing this. So next example illustrates this. If you want to execute echo this, then okay. So what does this echo $home will echo? Maybe you have this username foobar, home foobar, and then because of this, okay, you are trying to execute this file. So bash complains that this is a directory, this is not an executable file. However, if you want to echo it, whatever is returned by this, then this is fine because echo $home will return this quantity, this string home foobar, and echo that home foobar that will be here. That will be echoed.
Sir, why didn't the second one run?
Which one? This one?
The echo, yes, sir.
Yeah. So what does echo dollar home do? Dollar home is definitely your an environment variable standing for your home directory. Let's say this is home/foobar. So first this is executed. Like here ls/ is executed. This is first executed. Okay. And you are saying, okay, because of this is a, sorry. Because of this will be executed. This is treated as a comment. Yes or no?
Yes, sir.
What is the output of the comment? It is this string.
Sir, but it would run the entirety of the inside whatever it is in the codes, right? It should run echo dollar home.
No. Whatever is inside this is first executed.
Yes, sir, that's what I'm saying. It will
And
execute the
whatever
first.
is printed in the std out, this will now be evaluated in this current context. So what is the result of this comment? It is this string. Okay. So now think of this as dollar followed by this /home/foobar and then enter return.
Sir, dollar of?
This dollar is a sign that this is the prompt. Then after this evaluation, this thing comes here /home/foobar. What is the result of writing this comment? It is not an executable file, right? It's a directory. So bash says this is a directory.
Sir, it would execute echo of dollar home, right?
Correct. What is the result?
Sir, but if we run echo dollar home directly without any codes, it would just give the.
It will print it. It will print this. No problem. But because of this bad thing, after this evaluation, its std out thing will come here. This is very, very important. You should understand this. We will frequently need this kind of construct. Okay. This is.
So I have a question. A program can have like multiple output streams. One is like the std out, the other one is std err. So if a program writes something to std out, that's obviously being used by the backcodes. I can see that. But what if it prints something to std err? Will that be also be used?
There are ways to handle this, but this is only for std out. Okay. So some piping and all that stuff you can do to get
yes, like two arrow,
yes,
one and all of that.
Things. And how you get this thing in a string, that's a different thing. Let us not worry too much about this for the moment. Okay, so the output of this is the string home foobar. Agree or not? Okay, so as if you have written /home/foobar here and then typed enter. And this is the thing, this is the error message you expect.
Sir, firstly, it will replace the home with the /home/foobar, right?
Correct, yeah.
Okay, so basically we are doing echo of /home/foobar.
Okay, so that will be home/home/foobar, and that
Yes,
thing
sir.
will be placed
So why is
here.
it running it? That's what I'm asking.
You ask
I'm
it to
not
run.
getting.
No, without this code, it would not try to run it. Because of this quote, it is treated as a command. It will return /home/foobar. But then what is the command here after $? It is /home/foobar.
So sir, if we write only /home, I mean this $home, then also the same output.
Exactly. Yes. On the other hand, if you want to echo it once more, so once again, this part will be executed. The result will be home/foobar. Now you are using echo. This is currently the command /home/foobar. Okay, then it will echo it.
Sir, if it's running, it's just running echo, right?
Which one? This one?
No, sir, the other one.
Other one runs echo. But what is
Yes,
the output? Where will
output
it
is,
go?
so it will run the output also.
Yes.
Oh, okay.
Think of this as
Got
just
it.
literal substitution of the string.
Okay, so first we substitute it, then it will echo it, and whatever the echo was, it will run it again.
Yeah, just think of it. Replace this by whatever the output of this program is. This command is.
Okay, got it, sir.
Okay, yes. Here also there is a literal substitution, but this echo handles that literal substitution, not literal substitution, that substitution. Echo this, just print it, echo it. Or you can use it in other ways like ls. You can let this output be handled by ls. So it will be long listing and then you just pass it through word count. So how many files are there and how many characters, lines, letters, blah, blah, blah. Okay. And also
Sir, can we have nested commands in here?
No.
In general, do we have?
No. Nested
Okay.
comments, how can you do it?
I think the second set, like inner back quotes will close the outer ones.
Yes, exactly. That's what I am going to tell. If you have another comment starting here, then this comment will end there. Okay, so nested comments are not allowed. But you can separate these things by semicolon one after another. That is allowed. And then which one will go? Perhaps the last thing will go. But anyway, you can check it. I didn't try it. Okay, likewise, you can handle this. This will return the string /home/foobar, then /spl, whatever is there in that directory, it will be listed. Be very careful with this backquote notation because we are going to use it again and again later, particularly in the next section when we talk about shell programming. Okay, because this is the only way a function can return certain thing. There is a written thing, but this return is basically a returning of a status, not of value. So it's very important. What this does, this basically opens a shell in the non-interactive mode. And whatever is written in its std out, this will come to this shell to replace this entire thing. So this is also important. Every backquote type of thing opens a shell in the non-interactive mode. Okay, but it's not in this shell, it's in some other shell. So that is also one thing you must understand. Perhaps not now, but later we will see. Okay, so this is opening up a shell in the non-interactive mode. Execute this command. Whatever you see in the std out, this will now come to this shell as arguments here. Here there are no arguments, so that is treated as a command, and therefore this is an error. Okay. So you need to remember this subshell thing. We require it again. Okay, so instead of backquote, you can also use this dollar within this. This is another syntax. So instead of backquote, I could have said dollar within a pair of parentheses, this thing. This is another alternative notation. Another way of doing the same thing. How do we will typically use this backquote thing? Because it's syntactically much simpler.
Sir, can you explain the second last command?
Which one? This one.
Yes, sir.
Yeah. So a shell is opened in the non-interactive mode. It executes one command called echo $home. What is the output? Something like /home/foobar. Okay. That output will come here. Output will come here. And in this current line, it will be interpreted as ls/home/foobar : pipe word count. Then whatever the effect of that is printed here.
So what does that straight line does? I don't know what you'd call it.
Straight line means that pipe.
Oh, okay, got it. Pipe.
It's pipe. Yeah, it's a pipe. So whatever it is supposed to print, this will go to this pipe, and this pipe, then the word count takes that thing as input, and it gives a summary of number of letters, number of characters, number of letters, number of words, number of lines, something like that. And this is a separate syntax for doing the same thing. Okay, so don't forget this. Backquote or this $this thing, they open a subshell. Whatever is it ... or here, this is executed. Whatever is supposed to go to the std out will now be replaced here. In particular, you can set variables like that. So variable name equal to do something. Then the variable will simply store those values, whatever is printed in the std out by the subshell. Agree? Okay, I think you need more time to get used to it. Okay, there are certain things. The export thing is another useful feature. So suppose you define a variable and you want to continue to access those in the subshells. Okay. So for example, I am here. I'm defining something like this, a variable called this. And I simply say export this variable. Or during declaration, I can also use this export my name initialized to this. And you say my underscore full underscore name equal to this, but you do not export it. Neither during declaration nor after that. Then you open a subshell. And of course, this, if you look at this shell level, here it is 1, it should be 2. Then if you try to echo this variable, it's correctly echoed. Echo this variable, this is also correctly echoed because they are exported to subshells. But if you want to echo this variable, this will not echo anything because this is not meant for exporting. As long as you are in this SHLVL1, this shell, you can use this variable. But once you open a subshell, this variable is no longer defined. Agree?
Yes, sir.
Okay, so that's what export does. Export to subshells. Okay.
Sir, what if we export inside the subshell? It won't go to the supercell, right?
It will not go to the supercell.
And if we don't export it, then?
It still won't go to the supershell, I think.
No.
Okay.
If you define something and just exit that shell, then okay, if you call it a super shell will not get any value anyway.
So I don't think the subshells like talk to the parent processes. They only export it to the child processes.
It can only talk with the child cells. Yeah, it cannot talk with the parent shell. Yeah. So exporting is only for subshells, not for supercells. Okay.
And for subshell?
Mm-hmm.
I mean, for all the shells below this level.
Yeah, sub, all these things will get this value.
Okay.
Okay, and there is another way of setting this parameter, that is declare minus x. Anyway, look at it later. Okay, the command line parameters are called positional parameters and can be accessed inside shell scripts or functions. Of course, if you run echo or Firefox, they are, of course, these command line parameters are treated as it is written in the executable code. Okay, but if you write your own shell script or a shell function, then you can access these positional parameters using these things. Okay, the $* or $@ is all command line parameters in a single string. Okay, it should be string in a single string. $ has the number of command line parameters excluding that command itself. $0 is the command, and then $1, $2, $3 the first, second, third, blah 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 command line parameters. Okay. So inside your C function, you can access these as argc, argv, argv0, argv1, argv2, argv3. Inside shell scripts, you can access using the special variables. Agree? Happy or not? So these are equivalents of argc, argv. This is like argc, but excluding the comment. This is argc -1 basically. This is the comment. This is argv0, this is argv1, argv2, and so on. So in a shell script or a function which is also treated as a comment, these positional parameters can be accessed. $0, $1, $2. Okay, so we will give you examples. Okay. And you recall that your C programs can return a status or exit a status because it's int main. Yes or no? So the question is, where will this status, exit status, or return status go? The idea is that this will populate this special variable. Okay. Here, 0 means successful termination in the shell terminology, and any non-zero value means unsuccessful termination. So your exit 0 will return the 0 status, which means this program has terminated successfully. But if you say exit 1, exit 2, exit -1, exit -2, this will imply unsuccessful termination. And there is only one code for only one status symbol, status value for successful termination. And there are possibly multiple, I would say, statuses for unsuccessful termination. Why so?
So what's the question?
Okay, so in C, this is just the opposite. 0 means false. Anything non-zero means true. Okay, so that's a convention. Here, 0 means successful actually, and non-zero means unsuccessful. And by passing what non-zero value this is, the status is, you can actually distinguish how unsuccessful that termination is. Okay, actually, I would say there is a famous quote from Leo Tolstoy. I think it is in War and Peace. It says that happy families are all like. Okay, so that means 0. Successful termination. These are happy families. And the second part of that quote is every unhappy family is unhappy in its own way. So which way it is unhappy? That is determined by the status. That is the reason 0 is used as successful termination and non-zero value means unsuccessful termination, and how unhappy it is that can be obtained by looking at the status. It is typically an unsigned short or short integer. Okay. Anyway, whatever it is, you don't need to worry too much about it. So let us look at some of these things in action. Okay, in particular, I will explain this dollar question mark here. So I say ls without any space this. Okay, but there is no command of that name. Okay, what will it try to do basically? It will try to find a file or directory in the name with the name ls. Okay, and try to go to the directory and use that as a command, but no such file or directory. So this bash returns the status 127, a non-zero value. That can be obtained by printing this dollar question mark immediately after this thing returns. Okay. On the other hand, if you just wrote this command ls/, then it will be printed something like this. Okay. And now if you echo $this, it will be 0. Because ls exited normally, so it returned the status 0, exit 0, return 0, something like that. So this 0 will be printed. This will be populated here. Okay. And note that after every such thing, this dollar question mark will be overwritten. So if you had another echo dollar question mark here, what would you expect?
Oh, 0, so like
0, right? Because this echo is successful. This echo is successful, so it will return 0. So next thing it will be just 0. Okay.
yes, sir.
Okay. Okay. So, and you see these other things. So here what I am doing, I am writing a function. Okay. I'm writing a function. I will tell you, if possible today itself, how to write functions. Okay. And it says echo $0 is $0. This time it is quoted. Number of parameters is this. And all the parameters in one argument, it is this. First parameter is $1, second parameter is $2, third parameter is $3, and so on. This is the end of the function. Okay, so a function behaves like a comment. You simply say parameters A, B, C, D, E. So $0 will be bash because this is executed by bash. Number of command line parameters except this is 1, 2, 3, 4, 5. So it will be 5 is printed. And all the, I would say, parameters in one thing, that is A, B, C, D, E as a single string. First parameter is A, second parameter is B, third parameter is C. If you do not supply so many parameters, like just this followed by this, no third parameter, $0 will be bash, $hash will be 2, $star will be the entire thing as a single string. First parameter is this, second parameter is this, third parameter is empty, which means it is not defined. Okay, so this is basically an artificial example. And this illustrates how you can use these positional parameters. And do you see something? There is some greater than sign comes here. So this is what is called this PS2, the secondary prompt. So you say dollar, started typing something, and until this bash sees the complete thing up to this point, it knows that this command is not successful. Then it will issue the secondary prompt, PS2. After this, it says it understands that this is a function that is defined. It will store it somewhere and come back to the secondary primary prompt. So this is PS1 dollar. It's usually something much more than this. You will get something like a machine name followed by the current directory. This is the secondary prompt. This is usually this, at least in my machine. Okay, understood.
Yes, sir.
So instead of argc argb, I will use these things. And whatever that exit value is, exit 0, exit 1, exit 2, those things will be stored in $? What was the status? Okay, so variables can be set. Maybe a little bit I do. I want to have a break. Okay, so there is something called a read command, using which you can read variables. So echo -n, then you -n means you do not break this line. Do not put a line break after this echoing. Then you say read my name. So whatever you type here, it will go here. Okay. And if you may also read multiple things, first name, last name. And if you say something like that, the first thing will go here, then the remaining thing will go here. Okay. And you can also say read XY. Simply supply one value. That value will populate X, Y will remain undefined. Happy?
So this new line will terminate the execution of read.
New line will?
So will new line terminate the execution of read? Because for XY, generally when you use C in like C++, it will keep waiting for input until you
I understand your query. Yes, it will terminate.
Okay.
If you do not supply sufficiently many values, then certain things will remain unread. Okay, it's not like C.
Sir?
Yeah.
Sir, can you explain the third command, read first name, last name? And then when we put three separate strings, why does it give the last two to last name?
It's a convention. The first thing it will go here, and thing. And of course, if we have first name, middle initial, middle name, last name, then this will go to first name, this will go to middle name, this will go to last name. So here I am actually showing where you apply or you supply more things than the number of variables. And here I am demonstrating what happens if you supply less than the requisite number of things.
Sir, what if we want to read, suppose Phul and Kumar in the first name? So do we put inverted commas?
Commas, yes, I think commas will work. Try it. I think commas, not commas, quotes, double quotes. It should work. You just figure it out. Okay, so what happens? You just figure out, or just read these things in different read statements.
So I have a question. So let's say I have a C program that has argc and argv. Now using bash, my first argument is quotes my name. Now double quotes. Now will my C program receive the double quotes, or will it just receive what's inside?
It will receive what is inside.
Only inside. So the double quotes will be discarded.
Double quotes will not be. Double quote is meaningful only to the shell.
Okay.
Okay, but this is just to say if you want to include spaces inside the double quotes, this you can do. But if you do not supply these double quotes, the spaces means existence of spaces means this will be treated as different command line arguments.
Sir, it took inverted comma as the input.
Where?
I wrote 3 words and I enclosed for the first two of them with double quotes. Then it just read the double quote first word in the first name and then rest of it in the last name.
Oh, okay. Okay, so you work with it. Yeah, I don't know what will happen. So maybe these quotes are not understood. Identity statement. Yeah, so if you have some such situation, then you have to read this thing and this thing separately. Okay. So whatever it does, you have to, I mean, appropriately handle it. Okay. Yeah, it's possible, whatever you are saying. Yeah. So here possibly double quote makes no sense. It is treated literally. Possible. Yeah. Yeah. So read-only variables, which you cannot change, but you can give only the value during declaration. You can say declare minus R variable, then it becomes read-only. Subsequent changes no longer possible. Some of the default shell variables are read-only, but not all. Okay. And here are some examples. You say my name equal to this. Then if you say declare minus R my name, it becomes a read-only variable. Now if you want to change the value of that thing, bash will complain. This is a read-only variable. And of course, you can define a read-only variable during declaration, initialize. After that, you cannot do this thing, change this value of this short name. And if you simply say declare minus R, you will see all the shell variables, user-defined or default, that are used in the read-only mode. So this is bash options, some ID, process PID, parent PID, UID, user ID. These things are read-only things. So if you want to read, for example, UID, the shell will not allow you to do it because this is a read-only variable. So this is a user-defined read-only variable. Other things are user-defined read-only variables. Okay, but anyway, these are some features.
Sir, so does unset work on them or not?
Unset doesn't work on them. You cannot.
So how do we remove it?
You cannot remove it.
Okay.
Yeah. Unset will not work. So minus I option, then you declare it as an integer variable. There are some other things. A means an array. X means whether it is marked for export. So these are the, I think, minus R, minus I, minus A, and minus X, the most common declare options. Okay, so I think I need a little break. So maybe 5 minutes. I will just come after that. I will do a little bit on strings, arrays, associative arrays, and if time permits, on functions. Okay. Okay, so I will come in 5 minutes. Oh, sorry, I'm back. So let us look at a little bit of the shell syntax. And as you already understand, is that this shell syntax is much different from your C programming syntax or awk syntax. Agree, right? That is the reason we have to spend some time. Awk could be covered in just a single lecture. Shell programming will take time because the syntaxes are quite different from standard C programs. Okay. So simple variables we have used and their values are treated as strings. So let us first see what operations are permitted on string values or string valued variables. Okay, so here is a listing of certain things that you can do. So you just look at the slides carefully. There is not much to explain. So length of a string. And these are the situations where this using this curly brackets, curly braces is a must. Otherwise, what shell will do, it will treat this as $hash. $hash has a separate meaning, right? Do you remember what is $hash?
Number of parameters.
The number of variables.
Number of command line parameters. Okay. Therefore, if I want to see what is the length of my string stored in the variable s, I am mandated to use this curly brackets. You have to do this. Otherwise, it has a different meaning. $hash followed by s, literal s. Okay. This is the length of a string, and there are many other things. Substring of s from index I to end. Okay. This $I, it can be a variable or a constant, like 5. Okay. And substring from beginning to index I. So this is this. And you note that this minus a, there is a space needed here. Otherwise, it has some other meaning. Okay. So substring from I, index I, and of length j. This is the syntax for it. Okay. And of course, instead of $I, $j, I can use constant integers. Okay. And this array indexing is and string indexing is zero based. Unlike awk, this is zero based indexing. Okay. And this is concatenation of strings, $s1, $s2, $s3. Here, of course, there is not a necessity, but you can use these curly brackets in order to make things more readable. Okay. And this is inserting a substring at index I, something like this, 0 to index I. Then you insert this new string and then whatever follows. This is a way you can insert substrings, deleting substrings. Okay, 0 to $I and then the remaining part, I to j or I to j minus 1. This is simply deleted. Okay. So these are certain operations and here are certain examples. So I believe you can make it out very clearly. I am not explaining. Some things you should do, right? Okay. Okay. So now let us look at arrays and associative arrays. Let us see what else we can do. So not want to continue beyond 4. Let us see. So arrays can be declared using declare minus array name minus a. Okay. This is similar to, let's say, int name something. Okay. So there is a declaration statement here. Okay. There is no limit on the array size. It can be anything. So it will dynamically manage the array. Indexing is zero based. Okay, this is very confusing. In some cases it's zero based, some cases it is 1 based, but we have to accept life as it is. And array name can be indexed as array elements can be accessed by this array name. without any space within a pair of square brackets, the index, no spaces are allowed anywhere. Okay. Spaces have different meanings. So this is also not a space. Okay. So this is setting the variable, the indexed variable of array name, and they can be accessed like this. And once again, you see that this is very necessary. Otherwise, it will be $array name followed by possibly this literal string index. Okay. And the entire array as a single string can be accessed like this. Instead of index, you say at standing for all or star standing for all. Everything. Okay. And the indices, okay, where these things are stored, this can be accessed like this. Instead of this, you just say bang this. Okay. We will see examples. Okay. In fact, you can define, for example, array name 0, array name 1, array name 2, and then you can leave out array name 3. You can simply go ahead and say array name 4. Okay. So this thing still makes sense. For which indices the elements are defined. Okay. That list you will get by this. Array size is this hash. And if you do not say at, then basically hash array name will give you the size of the string stored in array name 0. Okay. So take care. In all these cases, these curly brackets are very, very necessary. Okay, so read-only array can be assigned only during declaration. No entry of a read-only array can be changed, even if undefined during declaration. Okay. And a read-only array or variable cannot be unset. Okay, and a question raised by you already. Okay, so here are some examples. Say, for example, you say I am declaring something like my array. Okay, then I can set 0 equal to this, 1 equal to this, 2 equal to this, 4 equal to this, 3 I am just leaving out. Okay, then I once again understand there is a problem with this, so I just reset this like this, 5 equal to this. Then if I print by echo 0, 1, 2, 3, 5, okay, 0, 1, 2, my array 3 is undefined, so it will just print a space here. And 5 is 5, 4 I have not printed. And if I print all the things, okay, at is all, and 0, 1, 2, 4, 5, 3 is left out here because it is not defined. And if I want to see the indices at which these things are defined, this is 0, 1, 2, 4, 5, 3 undefined. Happy? Okay. So like when I can have a Fibonacci array, it's an integer array. It's an array, and R means do you remember what R means?
Read-only.
Read-only array. So you can declare a read-only array, but subsequently you cannot change it. Okay. So this is another way, instead of doing things one by one. Okay, there is even a simpler way of doing it, and we will see. 0, index 0, it is 0, index 1, it is 1, index 2, it is 1, index 3, it is 2. This is one way. And then you can echo these things, echo the values and the indices that we defined. Fib10 is this. And if you want to set this thing, it will say fib is a read-only variable. You cannot set thing. Okay. And note that there are no spaces anywhere, because spaces have a different meaning to the shell. Okay. You cannot set my array. Because this is not declared as a read-only variable. But, and then once you want to access this 0th element, You see undefined thing, but you cannot unset fib, or for that matter, fib 1, fib 2, fib 0, whatever. Okay, cannot unset. This is read only. Okay. And what are the operations on array? It's a quick way of initializing. You simply say array equal to element 0 space element 1 space element 2 space element 3 instead of doing something more complicated like this. Okay. You can simply avoid these things. Okay, but this is more general because you can supply indices and leave certain indices out here. But if you initialize it this way, this will populate the 0th element, this will populate the first element, second element, third element, and so on. You cannot have gaps. Okay. But this is good. You can actually append this array by this plus equal to sign. So whatever is previously there, after this, these things will appear. The end of the array. Subarrays is similar. Okay, from index I to n, similar to your strings. Subarrays, elements starting from index I and of length j, it's this. Inserting elements, so syntax is very similar to strings. Only thing, everything will appear within a pair of parentheses. Okay. Deleting elements, compact indexing. Okay. Yeah, for example, if you have defined array 0, 1, 2, left out 3, 4, 5, 6. Okay. And then if you say this thing within the pair of parentheses, it will actually compact. Okay. This is a concatenation of two arrays. Okay, so here are some examples. I hope you can go through it. And if you have some problem, let me know. Okay. This is the syntax of doing certain things using arrays. Should not be very difficult to understand. Okay. So like awk, you can also have associative arrays where the indices are essentially strings, not non-negative integers. Okay. They actually have a very similar syntax. Okay. Only thing is that you declare it with minus capital A instead of minus a, small a. Okay. And they are indexed by strings. So integer indices are converted to strings. And the thing, I would say the accessing pattern is the same. Only thing, instead of integers here, you supply strings. And if you supply an integer value, it will be converted to a string, and then this hash value is accessed. Okay. And its accessing is this. Okay, so here are some examples. And now 0 does not map to anything, but this string maps to this. First name maps to this, lname maps to this. This is my info. This is initialization as an associative array. And you can add certain other things like this. Okay. And then you can say my info first name, my info lname, last name, likes games, this. Here you can see this. Okay. Okay. Now, this is yet another confusing thing. This will give you the set of all keys for which this value is defined, like name, fname, lname, CGPA, height, and mobile games. But the problem is that this will simply be a list of these things. So if something has a space like this, then now this for statement we will look at later. Okay, near the end. I'm just explaining this for all keys for which my info key is defined in some order. Okay, but you have seen a very similar thing for awk, right? What do? You echo this key maps to this value. And I am quoting this greater than here, otherwise it will mean, what does it mean without this quoting? Come on. Why did I have to quote this greater than?
So dereferencing something.
Or else it'll like pipe the output somewhere else.
It is called redirection.
So redirection, output redirection.
Output
the STD out will be redirected to a file with that name.
Exactly. So in order to prevent that, I am just quoting it. And then I print this, fname goes to this, height goes to this, lname name, but now mobile and games, they are treated as separate things. Okay. Agree or not? Because this is a flat listing of all these keys. And if there is some space there in that listing, this key will simply run over all these things without spaces. Okay, that is that this goes to this goes to this. But my info mobile is not defined, my info games is not defined. Right? Okay. Here is a way out. You just read it, and I say that it's a bit risky to use this. So be careful. I suggest that you do not use spaces inside these key values. Okay, there is a way out, but it is a risky business. Okay, so take care of this. Here is a way out, but I am not elaborating it. So this internal field separator, this is basically like field separator in awk. Okay, so what basically it will do, instead of separating these things, these keys, where is that? Yeah, it will say fname colon mobile space games colon height colon lname colon name colon CGPA. And now this for knows that colon is the separator. And then it can actually take out this. But here I have used colon. This is also treated as some kind of separator. And you will see that in the output, these colons have vanished. Okay, so be careful. I mean, you should not change this internal field separator. It has some side effects. Avoid using those things. Okay, anyway. Maybe up to 4 o'clock I will continue. Just 10 more minutes you give me. So you know what you can do with your strings, with your arrays, with your variables, with your associative arrays. But what can you do on your numeric strings? So this thing, let it be the last topic of today, arithmetic expressions. Okay. So this is the syntax, $, double open parenthesis followed by expression, followed by double closed parenthesis. Now this expression can have spaces. Okay, no problem actually. Inside this actually goes to some kind of arithmetic calculator. Okay. And the limitation of these arithmetic expressions is that they work only with integer variables. Floating point variables are not permitted. And strings are automatically converted to integers. Non-numeric strings and undefined values are converted to 0 in expressions. And you have standard integer operators like plus, minus, unary plus, unary minus, binary plus, binary minus. And then what? Star, slash, percent. Okay. Only thing you can also do exponentiation here. Double star is the exponentiation operator, which is not available in C. And inside this, you may have, literal numeric values, or you can use some $A, $B, $C, some variables. Okay. But the point is that inside this dollar you can supply for variables or not. Okay, it may be omitted. So let us see an example. A is initialized to 3, B to 4, C to -5. And you want to echo the result of this arithmetic expression, $A plus $B star $C minus 6. Okay. But it will be -23. But as I mentioned, you can avoid these dollars inside so that it looks better. So if you just say A plus B star C minus C, what does A, B, C essentially mean? They must be variables because they are non-numeric strings. Right. But 6 is not a variable because it's a numeric string. So the shell will try to get the value of A, value of B, value of C. It will substitute and it will evaluate this expression, and whatever the value is -22, that is equal to. And this is another thing, A square plus B square you compute and store it in Z, equal it is 25. And if you now want to divide Z by Y, Y is not defined anywhere. A, B, C, and Z are defined. So Y is division by 0. And if you define Y to some non-numeric string and try to do the same thing, this will say division by 0 because this non-numeric string is converted to 0. And here is another way of doing it. So I've been storing the first few Fibonacci numbers. 0th thing will go to 0. First one is 1. And then for n equal to 2, 3, 4, 5, 6. Fibonacci $n equal to $fib n minus 1 plus fib n minus 2. Again, you do not require this dollar thing. Dollar within the curly brackets, fib n minus 1. You can do this thing. Later we will see how we can do it in a loop. Okay, here I am doing manually. N equal to 2, n equal to 3, n equal to 4, n equal to 5, and n equal to 6. Okay, and you see that these are the values stored. And these are the indices at which these values are stored. Okay. And here is a way you can do some kind of floating point calculations. You can use this arbitrary precision calculator BC. Okay. Its default precision is 0, and this is how you can set the scale. And let's say I want to compute the approximate value of pi. You can echo whatever this is 22 by 7. Pipe it to BC, the calculator, whatever it returns. Okay. Stored here. You get the value of 3 because the default precision is 0. But if you say the precision to 10 and use this thing, then you will see a value like this. Okay, so you look at these examples. So it's a better approximation, 355 by 113. Both are in some sense the best approximations, but this is, yeah. Okay, I think I stop here because it's already a long class. So how much is left? Let me see. Okay, so I will complete the rest of this set of slides and a beginning of shell programming in the next class. Yeah, I think it's already a long class, so let us stop. The syntaxes are quite different, so you need to understand the differences. Okay. So let me know if you have any immediate questions up to this point.
So I have a question, but I'm not sure if it's relevant to shell programming. My question is with respect to like how like shells like load the programs into computer memory. Like what is the process through which that happens? Like how does the shell pass the arguments to the like program argc, argv arguments and all of that? What's the exact mechanism?
Okay, I would say that these shell programs are typically written in a C programming language, so it essentially does something like argc, argv. But exactly how it manages its memory, its arrays, its associative arrays, this is not transparent to the programmers.
So I'm not asking about these like features. I'm asking about like, let's say I write a C program, right? So and I compile it to an executable. So when I
Okay.
write /a or something, so what is the exact like process through which the shell like loads that executable into memory and like passes the right arguments and all of that?
Well, I think that's an operating systems question.
Right. So yeah, that's my question. Is shell like part of the like how does it
No,
interact with
no.
the kernel to like do all
It is an
this?
interpreter just.
It's an interpreter. It's usually it will always ship with the OS. Okay, but it's strictly like even so you always get it with Linux, therefore it's a Linux shell, but it's not really a part of the OS which does what you are saying it does basically.
So does it perform like a system call and like load the program into memory?
No, you can write your own shell, for example.
Okay.
Actually, in the OS lab, sometimes that's what was the first assignment we start with, writing your own shell with all those pipes and redirections and everything.
Yes.
You implement.
Yes.
To do that, you make system calls. Basically.
Yeah, this is more an OS issue. At the
Part
moment,
compiler, part OS, because the other thing that argc is okay, but the other thing, how is the thing loaded in memory basically? So will be, the role of the compiler and the loader basically part of that. But then it will have to call OS.
Question. So what is the interaction between the shell and the loader?
What is the interaction between the
Yes,
shell and
does
the
the shell simply like invoke some sort of system call to load to like call the loader, or is there some other like how does argument passing basically work?
Loader
like
is also strictly not. It's it's hard to explain the boundary basically. So yeah, for now you think that you make a system call, it loads it basically in memory.
Oh, okay, sir.
Yeah. Take it offline with us. I'll interact with you.
Okay, so sure.
Okay. It's a little bit hard for the class to understand. So.
Yeah. Anything else? Yeah, perhaps no. So let us stop. Okay, this is fine. I'll stop recording. Okay, I'll post these slides for you to read and experiment with your own shell. Okay.